Hi everyone, welcome back to Glodoram YouTube channel. This is the video that we are going to see what is the rebar detailing and what is the importance of the rebar detailing, as we have discussed what is the lab condition. So in this video that we are going to continue what is the lab condition that we need to follow for the rebar detailing. So before that please subscribe and share, like, and if there is any comment kindly do the needful, so that if there is any doubt in that rebar detailing I may go through and I'll give an answer about that. So before enter into this video, okay, let's get into this video. Before we have discussed what is the rebar detailing and what are all the things that we need to follow, we need to study two things importantly. One is the structural detail and another one is the architectural detail. From the structural detail only we are going to see step by step what is the important detail. So from that we need to follow concrete grade and steel grade, and then we need to go for the lapping condition, and before that we need to refer cover detail. So now we have discussed what is the lap and where we need to provide the lap. If opposite person comes to ask you, if opposite person will ask you what is the lap and where we need to provide the lap, there is a two rebar and rebar length 12 meter. So two types of rebar that we are going to connect by using a lap, and where we need to provide the lap that we call the lap condition. If you go above the superstructure, means above the ground level, that we call the superstructure. Below the ground level there is a substructure will be there. So superstructure there is one condition and substructure there is another one condition. What is the lap condition that we are going to follow? The superstructure, we need to provide lap at mid area in between two support, and for the bottom layer that we are going to provide lap at support area. Wherever the column support will be there, we are going to provide the bottom layer support exactly where the column support will be there. So this is the condition that we see in beam and slab. So now we are going to discuss about what is the lap condition that we need to follow for the column. For example, we are going to provide one column from one floor to another floor. So if for example we are going to take the total height of the column 6 meter, or else if maximum that we go and discuss about the column height for the high rise building, more than 6 meter will be there. For example, if we go and study that 8,000, okay, we will take example for the 8,000 height of the column, and we need to take the length. There is one length will be there, and we are going to calculate that length below means soffit level. Hope you guys know that what is a soffit level. If you go and see the upper floor, there is a bottom level of the slab, that is we called soffit level. So we need to take the dimension from the soffit level and to reach us of the what the normal level that we are going to take. So this is the length we need to consider, the total height of the column, and that height of the column that we are going to divide it by 6. We need to divide that length into 6. So there is some length will be there. So that length we are going to take bottom near support and top near support. We need to consider the zone A. Okay, we have to split it into 3 parts. When we consider into the column height, there is 3 parts will be there. One is above the floor level that we are going to start the column, and one is the below the length that we need to enter the column. So there is 2 types of length will be there, and that is the length that we call zone A. And in between zone A there is one length will be, so length will be there, and that is the length we need to call zone B. So what there is we need to provide as per the design, the design that we need to provide the lap at mid. But why we are not providing the lap at mid in column? There is an option to there is a lot of option that rebar corroded by the sunlight and air easier. If there is any option to, we are going to cast another level little later, so there is a chances of rebar will get corrupted by those nature. Before that we need to avoid that things, and we are going to provide the small length from the normal level of the slab, and we will all tie up, and we are constructed one column from one level to another level, and above level there is another column going to be constructed in the future, so that we need to provide some doubles into that. So that is the purpose also. Here in construction, in rebar detailing, we are going to lap in the support area, but as per the design that we need to lap at the mid, but here we are going to lap at the support area. So what is the support length? What is the support area? The lap length that we need to consider, meaning as we have discussed, the normal length that we need to go as per the design 50 into what is the sizes of bar. For example, if you are going to provide lap for the T20 and we need to multiply with a 50, so there is the length 1000 will come. So we are where we are going to start the rebar detailing for the column. From that floor we need to provide that 1000 mm. So is it enough to provide the 1000 mm? No, we need to add some kicker, cover, or something. We used to say allowance. Allowance meaning if there is any changes in the level, that 100 mm will going to cover those area. So that is we called kicker or else allowance things that we are going to provide. 1000 plus 100 we need to provide column lap in that support area. And where we are going to provide the lap, obviously it comes to the zone A area. and we need to connect another rebar with a lap, and we will continue as the same what we have followed for the previous column. So this is the condition that we need to go for the column lap. And if there is any lap that we need to provide the top zone A, no, we are going to provide one lap when we are going to start the column. So that area only we are going to provide the lap, and we need to end that lap the another floor, means above of the another floor that we are going to end that lap. So there is one column and there is one lap only we are going to consider for the column. If it's a smaller length, if it's a bigger column, for example more than 7,000 or more than 8,000, there is a column height will be there. So in that time we need to consider two method of lap will be there, and that is the one that we have discussed. We need to provide two areas that we are going to cover the rebar with a lap. We need to tie up the rebar with a lap. And what are the things that we are going to discuss in it, meaning wherever we provide the lap, there is option to fell down that rebar, because rebar is usually basically it has more weight, right? So only there is an option to fell down. So we are going to tie up with the more links. So wherever in column there is a lap area, that thing we need to tie up with the more links, so that the rebar will stand safer in that place and there is no chances to fell down. And it is more stronger things that we are going to provide the links around the lap in column where we are going to provide the lap area. That is the thing, we are providing links where we are going to provide the lap in the column area. This is the same thing that we are going to follow for the wall also. Now we have discussed what is the column, and there is maximum 4 to 6 numbers will be there, and that is the thing is easy for us to connect with the another rebar and zone A that we are going to provide the lap for the column. And what about the wall? The same thing that we are going to follow the wall also. Wherever the startup area that we are going to provide from the slab, we need to provide one lap, and then next floor, above the next floor, that we are end up the lap with one lap. So lap dimension that we knows already 50 into what is the dia of the bar that we are going to multiply. So these are all the things that we need to follow for the lap condition in column and wall. Maximum, why we are going to provide the smaller zone A, why we have followed zone A lap in a verticals. So that is the purpose that we have discussed, because we are going to protect the rebar by affecting by those out sources like outer thing like nature and sunlight. That is the reason we are going to provide the smaller length from the startup of the, from where we are going to start the column. In that area there is one lap, and where we are going to end above the slab, that there is a one lap. This is the same procedure floor by floor that we need to consider for column and wall. And in the same lap area, now we have discussed for the vertical element. And what about the starter element? So starter also we need to provide with the L bar. And if it's the basement, we are going to provide the L bar with the starter bar, and there is one type of length that we are going to follow for the lap area. And the below level we need to provide the hook, so that is a smaller length we need to follow for the starter area. Then what are the elements that we are go and consider for the vertical thing? This is the main thing that we need to follow. So both lap condition we have discussed, I hope. One is the slab and beam, that is a condition you know well. We are going to lap for the top layer, in between the two support, mid of the support or in between the two support, we are going to lap for the top layer. And the bottom we need to lap at support exactly, or else near to the support bottom layer. And beam also the same procedure that we go and follow for the lap procedure. And when we come to discuss about the verticals for the column and wall, we are going to provide one lap each and every floor, but we are going to connect with the rebar. And the next video we are going to find what is the important things that we need to take from the structural drawing. It's too easy for us to understand when we are going to discuss step by step what it's in the rebar detailing. Until bye.